Okay, listen up. So first one, we're tossing a pebble into the air from the top of a cliff, and we're given this equation for the height of that over time. Guys, sometimes it's super helpful to just draw a little sketch, and we're tossing this pebble. We know it's going to come down as part of a parabola. It's not going to be the whole thing since it's starting from some height. Okay, our equation, let me write that a little bigger so you can see it. So can you guys be able to interpret the equation, not just answer the questions about it? So what does the negative 16 tell us? I wrote this in your notes with you. If you are taking good notes, it's just a lookup. Yes, you should know it, but it's also something you can just look up. So I really should see lots of hands.
Force of gravity in feet, or half of the force of gravity.
Yeah, half of the acceleration due to gravity. That's not it. Okay. What's the 32 then? Yeah, so this is the initial velocity. Did the person throw it up or down? Up, because it's positive, right? It says plus 32, which means they tossed it up, not down, which we know you can do both things. All right, what's the 80? Yeah, where? The starting height. So it's the height of the cliff. Or maybe if we want to get super technical, it's the height of your hand when you released it. Maybe you threw it overhand, but. So let's call it the height at the start. The way I drew my little sketch, it looks like it's coming off of the ground, which is fine, but it's probably out of the hand. All right, it says, what is the maximum height reached by the pebble? So what is that maximum height called in math? Yeah, everybody say it. The vertex. It's that point right there. Is it H or K? The maximum height, is it H or K?
K.
It's K. Okay? What is H going to tell us? I'm saying in reality, what is H going to tell us? What was it? The time it takes to get to that maximum height, which probably is like a part of a second, right? It's going to be super fast. We're going to actually see that because in order to find K, we need H. So how do we find the H coordinate or the X coordinate of the vertex in standard form? Yeah, Anthony. H equals negative or opposite of B over 2A, which is opposite of 32 over 2 times negative 16, which is positive 1. And what is that labeled? Seconds, yep. Now, nothing in the problem tells you that. Like it does tell us we're operating in feet, but nothing tells us the time unit. The only way we know that is because we know that the 16 is feet per second squared. That's what brings in the time. All right, now we know that the time it takes to get there is 1 second, but to find K, which is the max height, what do? It's the Y coordinate of the vertex. What do we do to find that? Yeah, Spencer. Yeah, so plug in positive 1 to our function. Okay? So that is positive 1. And so we get negative 16 plus 32 plus 80. 80. Sorry, I didn't realize I was writing off the screen. Okay, negative 16 plus 32 is 16, and then plus 80, so that is 96 feet for a maximum height. Okay, so this is a process. If this was given in vertex form, how fast would this have been? To ask for the maximum height. Instant, pretty much, right? In vertex form, this would look something like negative 16 times x minus 1 squared plus 96, right? That's instantaneous. Oh, it's 1 second over and 96 feet up. So just know that both forms offer good things, but in this case, finding that vertex or maximum takes a little bit more work. How'd that go? Raise your hand if you got it. Let's do it that way. Awesome. Okay. All right, part B, or second question. So now we're looking at key features just from standard form, from the graph. And I would probably recommend sketching this first. Just sketch. Like, we don't even know for sure where everything is, but we do know some things. Where's the y-intercept? We know that right away. Remember, the c value is your y-intercept in standard form. So we know for sure that A is correct. And I suppose we could sketch that in here. Okay, next I would go to which direction does this open? Does it open up or down? Down. And since the y-intercept is here, it's probably doing something like that. Thanks. Can you just set it there for me? Okay. Does it make sense for the vertex to be -1, -4? I don't know. Let's go check. Maybe I drew it wrong. How do we find the vertex again? H is where? This needs to be pretty much memorized at this point, just so you know. If you're not, you're behind. So H coordinate of the vertex is what? So you guys have some work to do tonight. It's negative b over 2a, okay? Or opposite of b over 2a. So opposite of -2 over 2 times -1. Just pulling numbers straight out of the equation. And so that's going to be 2 over -2, which is -1. So part B is looking good. But we need to go double check that the y-coordinate actually is -4. It doesn't look probably likely that that's going to be true to me, because that would mean that our vertex is down here maybe, like that, which is the wrong way. So let's just check. The k value, or the y-coordinate of the vertex, we just plug in -1 to the function. -1 squared is what? 1, and then made negative. And then -2 times -1 is +2. So this is +4. So it's close, but it's the sign of the 4 is wrong. Also, that tells me that I drew my graph the wrong way. Did everybody see that? Meaning the other leg needs to have the y, it needs to go something like this. So that one is no good. Okay, axis of symmetry. Where do we get that equation? And remember, it's a vertical line, so you need to say x equals. Where does that equation come from? Here's our axis of symmetry. It's just going straight through the vertex. If it's a vertical line, it goes straight through the x-coordinate of the vertex, which we already figured out. Which is what? So it's x equals -1. Yeah, that one works. Okay, and then we already found the vertex -1, 4. These kind of questions are kind of a pain, I'll be honest. I don't personally like them, but they do force you to really work through an entire problem, don't they? Okay, so you need to be able to do them, like pick all that are true. Also, that gave us a pretty good review. But I kind of get the feeling that once we write these, sometimes people don't look at these notes, which is unwise. Do you agree? So I would be going back and reviewing them at least every night, or every other night maybe I should say, at least that often, but every night would be good. Okay, so quick review of standard form. Y-intercept is 0c. It's the thing that's given quickly in a standard form. Axis of symmetry was negative b over 2a. But we also wrote this is the x-coordinate of the vertex, which is h. And I don't know, maybe we didn't make that stand out enough. So if that helps, maybe make sure that's really obvious in your notes. And then we wrote about to find the y-coordinate. Just plug that into the function. Whatever you get for your x-coordinate, just plug it in, and that gives you the y-coordinate. Okay. In context, that's what we did on Friday. I think that's where we were. Remember, if A is positive, it's opening up, so we have a minimum. In fact, let's just add a little sketch to this. Sometimes that's worth a lot. If A is positive, it's opening up. Just sketching a little parabola in there. And if A is negative, it's opening down, so we have a minimum. Oh my goodness, do you guys see what I wrote in here? I totally wrote it wrong. Does anybody see it? You need better glasses. A positive, look what I wrote. Is that true? So we need to switch those. That's weird. I wonder why I did that. All right. Please switch those. I'm not sure what the heck happened, but if A is positive, it's opening up, so we have a minimum. It's kind of opposite of what you think. Positive, min, negative, max. It doesn't sound like it would be correct, but... Okay, well, that was a good thing we checked that. Okay. And then here's where we wrote about the components of the projectile motion on Earth, if you want to reference that stuff. So, any questions on your homework? I'll show you what, I do want to review what we did with that, but... Yep. What? Okay, so we're going to look at 23. I'm not sure we'll do the whole thing, but we'll look at it. And then any others, we'll check them. So just as a reminder, where am I here? Oh, I'm on the wrong one. Friday, we learned also how to write the equation using 3 points. So like these two, remember that was a system of 3 equations that you had to do and solve for A, B, and C. So let's set up number 23 as a review of that. And I'm going to go this way. All of these are going to use the standard form equation. I'm going to set it up like this, though, with the y on the right side. So in the first one, A, B, and well, x is -1, so we'll go A times -1 squared plus B times -1 plus C equals, in this case, 5 is our y coordinate. And then number 2, now x is 4. 4 in for all the x's, and this time y is 0. And then third one, x is now 5. And y is negative 7. Are you good so far? Now we need to clean those up because they're not super functional the way they're written. Does everybody see where those came from though? At least as a start. Okay, so 1, again, all we're doing now is just putting the variable second instead of first. So negative 1 squared is just 1. And then we get minus b plus c equals 5. And number 2, 4 squared is 16. And then 4b plus c equals 0. And let's get this out of here. Okay, 5 squared is 25. And 5b plus c equals negative 7. So that looks more like a typical 3-variable system that we're used to. And we said always start by solving for what? With these ones in particular. Yeah, because we'll always have plus c on all of them. So you can just subtract 2 different versions and get rid of c, and that gets you off to a good start. So like 1 and 2 maybe. 1 and 2. And you're going to subtract and then do like 1 and 4. Sorry, 1 and 3. 1 and 3. Going to subtract again because that's how we get rid of the c's. Okay, and then back plug in. Yeah.
So I have a question. So do we for the after
Elias, pull out your calculator.
after you get the this case do you plug it into the remaining the equation and using the cells?
Yeah, so well, you're going to eliminate c. Everybody listen up. There's questions that might be helping you. So you're saying you want to solve for b from the results of these two, correct? Okay, so then the best idea, this is going to generate equation 4, and then this will generate equation 5. We'll combine those to get b. Take b back into one of these. Probably I would go to 4 or 5. Once you get b, now you have b and a. Probably in this case, I would go here to get c. Yeah, does that help? Guys, I'll show you the answers here in a second. How do we do this kind? Number 25. Also, it's the same question. How can we check 23 and 24 instead of doing it by hand? How can we do any of them? Desmos, and we're doing a regression, right? I showed you that. I'm going to show you on a calculator what that looks like. But basically, we're just entering the data. So we're going to go, in this case, to regression. And we're just entering our x's, which were 0, 0.5, 1, 1.5, and 2. So I know not everybody has this calculator, but it's the same on a TI. So 0, 0.5, 1, 1.5, 2. Just entered all the x's, and then you go do the same thing for the y's. 35, 36, 29, 14, negative 19. 5, 36, 29, 14, negative 19. Okay, so we just enter our data. Same thing on Desmos. Insert a table. I can review that with you just shortly. And then it does in this case tell you to use regression, but if it just gave you this kind of problem on a test or something, just know you can use it for that as well. Okay, and then we just find a regression, so it's kind of nice. Go up here to stats, and actually that's not it. Let me go back to graph. And regression, go up to regression. Are you following? Okay. What should I pick out of this list? You have to do this on Desmos as well. Yeah, let's try quadratic. Okay. And give me my line. There we go. It's kind of an ugly looking one, but there's our function rule right there. Do you need all those decimal digits? No. Okay, let's review Desmos real quick. So you go to plus, I don't know why it doesn't fit on here, but you hit that plus sign in the upper left, and then you pick, oh, this is annoying. It says table, so just insert a table, and it creates that. Am I zoomed in maybe? Yep. So table, it inserts that. Just put in some data. 5, 25, or something. 10, 32. Okay, and once you do that, remember it has this little thing right there. It's a line with dots. I'm not sure what it looks like otherwise. Once you click that, it brings up your choices for regression. So just pick whichever one you're doing. In this case, it'll be quadratic. Okay, so that was kind of a review of last week. How do you feel? Okay. Let me show you the answers to the homework then. Go ahead and pull those out. So, well, the first one was 23, right? Right? Okay, 23 then. Negative x squared plus 2x plus 8. That was the equation once you solved for all those. 24 was 2x squared plus 4x plus 2. What was the next one? 25, negative 16x squared plus 10x plus 35. And then which one? 26, negative 3.5x squared plus 3.35x plus 0.7. And those two, I had you just do the regression on Desmos, so that should have been like 1 minute apiece. How did the longer problems 23 and 24 go when you did it by hand? Did you do it? Okay. So you still need to be practicing that. Make sure you can do those. Any questions on finishing that up? On standard form, I mean. Give me a fist of 5 on standard form only. Fist of 5, please. Okay. We'll talk. Overall, that's looking pretty good. Grab your notes, please. All right. Third and final form is called factored form or intercept form. And some of it will look similar and some of it is going to be, it'll show us something else. So I'm sure you'll have a favorite after we get through all three. I couldn't tell you what mine is. I like things about all three of them. But here's the thing. How do you think we get it in this form? Factoring, right? Factoring for sure. So, I mean, we can be given it in this form, but we also need to be able to put it in this form by factoring. So let's see how this is going to go. I don't have this for you. I think you can probably just look at it. I'm gonna jump right in with GCF. If that goes well, we'll skip all those slides you saw me go past. Hopefully it does, but guys, what is a GCF? Okay. So we know what the letters mean. But what do you do? Like, what does that mean when we factor with the GCF? Like, if we're looking at this first one, what is the GCF? Because most students want to look for numbers, which is okay. But really, we want to look for letters more. Here's how I'm going to write it. In terms of factoring quadratics, or factoring anything for that matter, your letters are going to be way more important in breaking down a function to a simpler version than the numbers are. Next unit, we're going to use this a whole lot. So please make sure you get this. What is a common factor of x cubed y squared and x to the fifth y? What can I divide both by? Yeah. Go ahead.
Sorry, I was asking to repeat that.
What's a common GCF of both of those two pieces? Okay, well, I'll just tell you in this one. Nope. There are no number common factors. Okay? Do you see both of these have x's and y's, first of all, right? So I want to pick the most x's and the most y's I can take out from both of them. So do you see how out of this one I can divide out x cubed and also out of this one? But I can also divide out a y from both. Over here, I can only pull out a y, that's the most, which means I can only pull out a y from this one. I can't go bigger than that, even though there's more to deal with. Okay? So in terms of factoring, I would pull out x cubed y out front of parentheses. And what's left over is, when you divide, it's just what your quotient is. So what's x cubed divided by x cubed? No, it's 1. Okay? What's y squared divided by y? It's y. Okay? So inside from that first term, I'm left with y. And then what's x to the fifth divided by x cubed? It's x squared. Okay? And then the y's cancel to 1. I'm going to just make this a plus for now. Okay? So that would be how we GCF factor those two. Again, if it didn't say and, if it said plus in between. Okay? So what did you learn about, well, these, for some reason, this is like the nemesis of every student, is exponent rules. We're going to have a whole unit on exponential functions, but what did we do with the exponents when we divide them? Because anybody remember? Like here we did, this became 1, the whole thing, but what happened to the 3's? Yeah. Subtract. Over here, 5 minus 3 is 2. I should have left the y squared there, sorry. Y, yeah, never mind. Plus x squared, that's better. Okay, so over here, 5 minus 3 is x squared. 2 minus 1 is just y to the first power. Does this look familiar?
In a way. Where is it now?
This is algebra 1. This is not, yeah. Okay. What's a good GCF for the second one? What goes into everything? That's what you want to look at numbers. You want to look at letters. Spencer? GCF implies we want the biggest thing, not just something. But thank you. Guys, what goes into 8 and 28? What is the biggest thing that goes into both?
2.
Wow. I don't know what you guys did this weekend. How about 4? Anthony, what goes into the A's? What is the biggest thing that we can pull out of them? Okay, do you see that? Does everybody see we can pull an A squared out of both? Okay, so our GCF is 4A squared. But what's left over from both terms?
2.
So 8 divided by 4 is 2. Good job. A squared divided by A squared is just 1. So that's just 2. Okay, second term. 28 divided by 4 is what? 7. A to the 5th divided by A squared is? A cubed. Okay, so that would be GCF factored. Guys, it's 5 minus 2. Okay. All right, how about this one? How about the next one? Is there a GCF for this one? Does anything go into 4 and 9? Does anything go into x cubed and y to the 5th? No GCF.
Do we leave it right there?
Don't, yeah, it's fine. Don't force it, right? How about this one? Start looking at it. Hey, we're getting better. So I heard 4. How about A's? A to the 4th, good. You can say B, it's either one. B is the same as B to the 1st. Okay, so our GCF, remember you pull it out front, A to the 4th B. And what do we do with the minus? Does it change anything? Just make sure you put it in as minus. Just watch your signs. That's all I'm asking you to do there. Okay, 12 divided by 4 is 3. 16 divided by 4 is 4. All right, what is A to the 5th divided by A to the 4th? Just A. And then B divided by B is? It is 1. 1. Not nothing. Okay, A to the 4th divided by A to the 4th. What is that? 1. So we just leave it. And then B squared divided by B is B. So there's your factored form, GCF factored form. Okay? You guys try this last one. I'm going to make it a plus in here. Plus. Go ahead and try that one.
Talk to me, guys.
What is the most amount of x's, most amount of y's, and most amount of other numbers? Why? It's the same. Are we seriously almost done?
Yeah, there's like
What? My word. 1 is never a GCF because it doesn't break things down. Yes?
What is 14?
No, that's not what we're saying.
Well, I know.
Yeah. We're not solving for x. No. How many x's can we pull out of both? 6. You see it? All right. The biggest number of x's is x to the 6th. And how about y's? Y to the 8th. Okay, that's our GCF. So x to the 6th, y to the 8th comes out front. Can I pull any numbers out? No. Don't pack it. X to the 10th divided by x to the 6th is what? X to the 4th. And then the y's are just 1. And then we have our 15. The x's are 1, x to the 6 over x to the 6. And then how about the y's? Y. Okay. So that's GCF factoring. Now, let's bring it into context of what we'll do for factoring. Something like this. Okay, this is more like quadratics. Let me show you what I mean. What goes into all the numbers? Now, I'm going to say pull out a negative 6. And the reason why is we want this term to be positive. Okay? What goes into all the y's? Y squared. Okay, so our GCF is negative 6y squared. What's left over from the first term? 3. What's y to the 4th over y squared? Okay, 3y squared. And then we get negative 6 over negative, or 6 over negative 6. That's negative 1. What's y cubed over y squared? Y. What's 24 over negative 6? Negative 4. Okay, stick with me, please. That's GCF factoring. Now we need to take this piece and take it to the star. Okay? Just the inside piece. Star. Remember, I've shown you this before. What is A from just the inside? Just the 3. Okay, so what's C from just the inside? Negative 4. So A times C is negative 12. What is B from just the inside? Negative 1. A is just 3 from the inside. Now, are there numbers that multiply to negative 12 and add to negative 1? Can you think of some? Negative 4 and positive 3. Everybody with me on that? Okay, next step, we take each of these and see if we can simplify them. That one is fine. Over here, we can simplify, meaning reduce these to 1 over 1. 1 over 1. I don't know why I wrote x. Okay, these come down and become our factors. Remember, the top number goes with x, so it's 3x. And then we just write the sign of the bottom. Guys, I don't see you till next Monday. I'm going to post some work for you to do. I'll see you Thursday. No, that's sort of true. We're going to have a drill on Thursday. So. Never mind.